Hey everybody, this is Larry. This is day 22 of the March Leetcode day. Trying to the like button, the subscribe button, join me on Discord, let me know what you think about today. Today's farm and stuff. I went to the gym today. I just didn't have my A game. I don't know why. My groin's acting up a little bit. I tried to do squats. I didn't finish my whole workout, but I was able to do it, but I don't know. I don't know if I'm just too tired or, been yawning a lot during the workout. We'll see. We'll see. I mean, we'll have good days, but bad days and everything. But I'm not even lifting heavy yet, so it's a little bit disappointing. But I am also, I had recently come back from a wind injury, so I'm also just taking it a little bit easier and a little bit building the foundations around it because I haven't squatted for I guess actually, I was gonna say a long time ago, but I think maybe actually June of last year. So that's like 9 months ago almost. So that's a long time ago. The reason being that I was training for the marathon, and at the tail end of that marathon, I just at the tail end of the marathon, I just could not run 60 miles a week, and also do squats at the same time. And then after that, I spent a couple of months just burned out from training, and here I am. So maybe it's not that unreasonable. I need to kind of build it up more slowly, but it's still a little bit, You remember how good you used to be, and it's just a little bit sad, but it's okay. We have time, maybe. Anyway, let's take a look at today's problem. We have 2685. Count the number of complete components. Seems like we've been having a lot of connected components problem recently, so let's take a look. You're given an integer and the undirected graphs of n vertices numbered from 0 to n minus 1, okay? You're given 2D integer array, edges, okay, you have two edges. Return the number of complete connected components of the graph. A connected component is a subgraph where there exists a path between any two vertices and no vertices outside the graph. So basically like a completed graph, right? Okay. I mean, n is equal to 50 is actually interesting. I don't know. Does it have to be that small? I guess the graph is pretty big, but yeah. I don't know if there's anything tricky about it, but just n is equal to 50. Maybe if n is bigger, we might have to think about some optimization, even though I don't even know one off my head. But otherwise, I think just getting the connected component and then do an n square loop on it. And if n is 50, it doesn't, yeah, it doesn't matter, right? Yeah, because your biggest component will be just 50 square, or 50, biggest component will have 50 nodes, which is going to be 50 square anyway, right? So I'm going to read, kind of be a little bit better notations. And here we convert to adjacency list, right? Oops. And here now we want to connect the components, and there's so many ways we can do about it, right? Yeah, I mean, I think we did yesterday or the day before. I don't even remember anymore. These days, I need more sleep. The last couple of days, I think yesterday maybe, we did a breadth first search one. So we could do that again because I feel like it seems reasonable to do, right? So we just have a node, right? And with Q is equal to collection deck. We have a maybe scene is equal to a set. And the reason why this is actually important is because otherwise you get n square if you allocate n space every time. But again, n is only 50, so it's not a big deal, but it is something to kind of remind yourself when for other problems when n gets pretty big and you want to keep it linear, right? Or I mean, alternatively, you could also just have, have it outside, right? So it's not. There are a couple of ways you can do it, but yeah. So we have scene of node is equal to true. Q dot append node, and then we have maybe just like a current thing, like a current set of nodes for this one, and maybe we start it. I mean, we could do it empty, all right? Then current is equal to q dot pop left, we want to, oh, this is awkward, right? But maybe this is current component, maybe. Yeah, and then current component, we want to append current. And that's it, really, right? So for we in adjacency list of current, if not seen of we, then we mark it as seen, and we also q.append we, right? And really that's it. And then now the reason why we have this current component thing is so then now we can just do yeah, I think one thing that would actually change is that I usually do a list without thinking, and I did not think, but maybe we should do a set. And the reason is because then now we can do lookups quickly as well, which is actually useful here for when you do like for you in current component, for we in current component, and maybe you could do it a little bit better. If you is not, you go to we, and maybe, okay, fine. I'm just being a little bit lazy, and this is twice as slow. You can write something like m is length of current component, right? I think this is a pairwise too, right? Is that what pairwise does? I don't remember. Actually, let me be a little bit better in terms of long-term things. Pairwise, create. Now, pairwise is is there a combination? Either tools.combination? Yeah, maybe. Maybe that is what I want. I mean, we can definitely, I mean, the for loops are not hard to write. I just want to learn something a little bit. So yeah, so we can maybe do something like this, right? So for C in combinations, right? So it should give you C of, maybe UV is equal to C, and then if adjacency list of U or V is not in it, then we return false. Otherwise we return true, right? And then now we can just go through the entire thing, right? Or V, I suppose. And then if not seen of I, we do a BFS on I, right? And we want, is it connected components or is it connected nodes? Okay, so yeah, so if we increment count, return count, otherwise we set count is equal to 0, and we're really happy, we're really Gucci. Unless it doesn't work, then we'll be very sad, but for now it is okay. So we're happy enough. 17-day streak, and we are sufficiently happy. Yeah, I mean, I think the key thing is noting that n is up to 50. So then this n square thing works with the combinations. Otherwise, everything else is linear, right? Honestly, this is the only thing that's non-linear. Everything is linear. And I say linear not in V, but in number of edges, right? Because you're going to go for, and edges can be V square, but that's still linear because that's the size of the input. So yeah, so we definitely could do that. But yeah. So do I have? I think that's all I have for this one. Yeah, let me know what you think about this. I mean, it's just BFS. There are a number of ways you can do it. But it gets dominated by this, which makes it n square. The way you can analyze it is just that if you have, like, you want to maximize this, how would you, or maximize as in getting the worst case of this? Well, you just have everything in one component, and this will be n square. So this is why this is n square. And yet it gets dominated, right? Because you have a curve that goes from n to n square, if you want to think of it that way, in terms of number of connected components. But yeah, that is all I have for this one. Let me know what you think. Thanks for watching. And yeah, there's also the, I was going to say bi-weekly, but the weekly premium problem, so I'll do that next. Thanks for watching. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.